a wonderful person, Yu Lee, joining us from joining us from New York. And oh, Rin is unsure if they are a member. We'll get the secretary, the cat Willow, the beautiful cat
Oh my
Willow, to
God,
check.
Willow, yes.
Please, Willow, get on it.
We must know.
We know you live there rent free.
Do your job, Willow.
Do your job, Willow. But welcome you. How are you doing?
Good. Hi, thank you for having me today. Really excited to share my project.
We're so excited to hear about it.
So, because my project is a little bit sensitive, I made a presentation to show it, and with I didn't show many image in the presentation due to the sensitivity, but I will try to present it in a good way. And yeah, I didn't want to ruin this whole live streaming.
No, we're happy to have you and super excited. The people will love it.
The people are gonna love this.
So I will share my screen then. So here is my work joystick. It is a sensitive old control game. This game, here's a demo with a blocker. And this is an old control game that explores various kind of joy, including those found in gaming, sexuality, and intimacy. And I also want to mention that this work is also inspired by the penis wall in like 10 years ago, which is a Kinect penis wall. So you can see on the picture, here is the game. You will interact with a penis-shaped controller, and it will trigger the balloon to grow. And how does this game work? So there are three main components in this game: the player and the controller, which use sensor and a microcontroller. And there's a game engine where we show the game scene. So this is the microcontroller I use. I use Teensy so that I don't need to deal with the serial communication. And it makes my process really smooth. And here's the sensor I use. It is a soft pot sensor. Oh, I also have this with me. Can you see it? And the game engine, I use Unity, but I believe that we can also use different game engine or just use JavaScript like P5.js. And the process, here's how I decide why I use these components. So to detect the hand motion when the players are interactive with the controller, I first thought about using a slider sensor because I was new to hardware and physical computing. So slider sensor feels really easy to build. But the cons is that it wears off easily, and there are just limited length options for building the whole controller. So that I also discover soft pot sensor. It is also really easy to work with, and there's a adhesive in the back side, so it's really to attach the sensor. And there are also various length options. There are 100 millimeters, 200 millimeters, and even like I think 500s. And I end up using the 100 millimeter one. But the cons is that it only works on flat surface. And so another option my friend suggests me is to use the capacitive switch. And it's the pros is that it can work on thick materials. But I didn't use this in the end just because I have limited time to build this project. But if I could have another chance, I probably should have used this one. So after we have the sensor, is what kind of materials we can use is I also think about if I should use a commercial project instead of using like a handmade material. so if I use a commercial product, it would be really difficult to customize it. For example, I might need to send the surface, and I might need more custom fabrication. So that's why I didn't use a commercial product. So also another friend also suggests me just made one with silicone. The pros is that it's really real and silicone is bendable. One cons is that with silicone, it's really hard to attach the sensor. So I end up just using a 3D print model. Before I use a 3D print model for the Peanuts controller itself, I also thought about using a wooden stick. But most of my friends suggest me not use a wooden stick just because it's not real enough unless I have exceptional sculpting skills. And so after using the 3D print models, the outcome of the controller is a black model. And here's just a note of, because some people ask me why, how did I pick a color? So the color of that 3D print model is just what was available in the 3D printer. So there are no design decisions in terms of the color of the controller, in case people are curious. And here is the testing when I was testing with the soft pot sensor. So it's just using a wooden stick to test how the soft pot is working. And when you touch the sensor at the button, you will get a 0. And if you touch the top of the sensor, you will get a value of 1023. So in terms of the game programming, from the sensor's value, it's really easy to trigger the balloon to grow. So the logic in the game is just when the user touch the button and the top of the sensor, the balloon can grow. So the programming part was really simple. And due to the sensitivity of the game, I also made a case for the controller. So here's when I was laser cutting the enclosure with wood. So the case looks like this. And some of the feedback I got from my players are, what if we can make this into a wearable game controllers? Because I also saw that people playing with a different direction. And some players would love to have VR visuals. And I also believe that this could be a fun experimental project if this becomes a dual or multiplayer game. And there's also another player suggests I should make it different sizes for accessibility. Yeah, so this is the most of the project, and I feel like maybe people would love to see the complete demo video, so I include the link here. In this link, tinyurl.com/oshawa-joy-stick, you can read the full documentation. And if people want to chat any feedback regarding the project, feel free to reach out to me on my socials here.
Whee! Amazing. Thank you for telling us more about the joystick. We were really lucky to get to see the joystick in person at the Open Hardware Summit this year, and it was a real hit. People loved seeing it.
It was so much fun. It was really cool.
And Chipperdoodles, as always, right. Open source hardware is about embracing your whimsy, and this is a really great project for embracing that things can be strange and unusual and fun, and that's okay.
Yeah, I think the reason why I picked this project was because I was also curious about what if different kind of human body parts can become controllers. Mm-hmm. And besides exploring joys, I was also thinking about if this game can amplify human agencies. For example, if the players who controls the controllers gets the power. So sort of like a shifting of power dynamics from the peanuts to the players. And another feedback I got in terms of the concept is that because right now the controllers you interact with it only mostly vertically or horizontally, and that feels like it's serving the controller instead of you are controlling it. So if I want to amplify the concept of power dynamic shifting, maybe I should enable players to bend the controllers in a 360 degrees. And to achieve that, I would definitely use silicon so that the players can control, bend, play with the controller in any ways they want.
So do you have, you're talking a lot about working with silicone and electronics. Do you have any like tips or suggestions for people who might be curious about doing similar things?
I actually have not worked with silicon, but I would say it really when I saw some of the artists I know working with Silicon Valley, they really take lots of time to model the case first, so that the output from the silicon would be more accurate. It definitely takes many times to have the results they want. And for me, I before I made joystick, I was mostly a software person. For me, I found that working with software and programming or code is really forgiving because I can always have version controls. I can always save, delete, and modify my code. But for working with hardware, I realized things just don't work as I expect. For example, I follow the instructions. I check the documentations, and sometimes there are just things not working. And maybe there are bugs, or maybe like this hardware is not feeling a great move today, or sometimes it's just some stupid reason. For example, the controller is just broken and not working at all. So I think the thing I learned the most is just it takes patience, and it's okay to fail many times.
Oh yeah, for sure. Sometimes with hardware, you just have to like give it, like let it take a nap and then try again later, and then it works. So
It's true.
it's true.
Hardware is a mystery.
Yeah. Well, thank you so much, you. It was so great to hear more about your project and looking forward to seeing the next iterations of it. Thanks so much for hanging out with us.
Thank you for having me.